introduced to you by a friend. You were cute and all that, baby, you set the trend. Yes, you did. Oh, the next thing I know, we're down at the cinema. We're sitting there, you start kissing me. What's that about? You're moving too fast, I don't understand you. Oh, I'm not ready yet, baby, I can't pretend. No, I can't. The best I can do is tell you to talk to me. It's possible, eventual, love will find a way. Love will find a way. Don't say you love me, you don't even know.
In this problem, we're going to graph exponential functions. Let's take a look. We have f of x is equal to 2 to the x power. So let's evaluate that base function. F of 0. We have 2 to the 0th power. Remember, anything to the 0th power is 1. We'll analyze f of 1 as well. 2 to the first power gives us 2. We're going to continue to work our way through these evaluation problems. F of 2 will give us 4. F of 3 will then give us 8. Now let's do the negative domain values. F of a negative 1 gives 2 to the negative first, which is 1 half. F of negative 2 is 2 to the negative second power. That will give us a value of 1/4. And similarly, f of a negative 3 will give us 1/8. So these are the values we're going to use to graph the exponential function 2 to the x power. We'll do that in red over here. We have 0, comma 1, 1, comma 2, 2, comma 4, that in there, and 3, comma 8. On the left here, at negative 1, we're at 1 half, and it begins to get a little difficult here as we graph these problems, negative 2 and 1/4, so on and so forth. So we're going to connect our dots here with a nice smooth curve. Note that this graph cannot cross the x-axis. The x-axis for this problem is known as a horizontal asymptote. So there is f of x graphing the exponential function 2 to the x. Now that we have the graph of f of x, let's use that to graph g of x. Let's take a look. G of x is the exponential function 2 to the x plus 1 power. And notice in here we have a plus 1 in the exponent. That's going to be a transformation that we learned earlier, and in this case it's going to be a shift 1 unit to the left. So what we can do is use the points from f of x and shift each of those over to the left 1 unit. You can see those indicated in blue here. And from this we're going to create the nice smooth graph of g of x, and it gets a little tied in here at the bottom, but the shape of the graph has not changed whatsoever. The red graph has only been shifted to the left 1 unit. And from this we can see a nice graph of g of x, the exponential function 2 to the x plus 1 power.
To graph exponential functions, the following steps should be considered.
1. Construct a table of values x and f function. Step 2. Plot the resultant values on the rectangular coordinate system. Step 3. Connect a point that will connect the lines into a straight cord.
In this lesson, let's learn how we graph exponential functions. So we will do a problem where we will create a table for the function given to us and use it to graph it. So what is an exponential function? An exponential function is usually written as a1 times r to the power of x. Okay? What is a1? a1 cannot be 0, right? a1 cannot be 0 because you can't multiply everything by 0. r is greater than 0. r is always a real number. And x is not equal to 1, right? X cannot be equal to 1 because then the degree would be 1, which means, let's say this was 2, 2 to the power of 1 would be 1, right? Or 2. So these are the rules. A1 is not equal to 0, R is greater than 0, and X is not equal to 1. If we have these conditions met, this is the format for a exponential function. So let's look at the function given to us. A1 is not equal to 0, R is 3, which is greater than 0, and X, we're assuming, is not equal to 1. Okay? So if this is the case, let's do this. Let's create a table on what happens when X equals -2, -1, 0, 1, and 2. And let's find the value of the function. What's the corresponding value? Okay? So here's what we'll do. If X equals -2, what do we get? Well, function X is 1 over 3 times 3 to the power of X. Okay? So if X equals -2, what do we get? Function of -2 equals 1/3 times 3 to the power of -2, which is 1 over 3 times 1 over 9, which is 1 over 27. Okay? So this is 1 over 27. If X equals -1, what do we have? I'm going to erase this part. Okay? Let's do it again. If X equals -1, what are we left with? 1/3 times 3 to the power of -1 is 1 over 3, which is 1 over 9. So this is 1 over 9. If we want to calculate the value of the function when X equals 0, that's 1/3 times 3 to the power of 0 is 1. So that's 1/3. Right? If X equals 1, I have 1/3 times 3 raised to 1 is 3, which means 1. Right? Similarly, what happens when X is 2? That's 1/3 times 9, which is 3. So now that I've plotted or created the table, let's use the table to plot the lines. Okay? When X equals -2, this is 1 over 27, which is very close to 0. When X equals -1, it's 1 over 9, that's approximately 1/10. When X equals 0, this is 1/3. X equals 1, Y equals 1. And when X equals 2, Y equals 3. Okay? Once we have these points, we can draw the graph through the points. As we can see, an exponential function is always a curve. Okay? What else are we supposed to do? We need to use the graph to estimate what is the value of the function 1.5, which means what happens when X is 1.5. If X is 1.5, Y is right here between 1.5 and 2, so function 1.5 is approximately 1.75.